All right, welcome back. In this session on the Core 1, Video 6, we'll be talking about the manufacturing equipment. So moving beyond the bucket and brush, we'll look into the guts of how a lot of the lamination equipment works and give you a good insight to how to use the equipment. So for a lot of the equipment we use, because of the nature of the materials, they're flammable liquids, but we're not going to use electrically powered equipment. So what we tend to use our air-powered equipment. So this is here is an example of an air motor. In a couple slides, you'll actually be able to see a real air motor. And how this works is the air motor is a big piston system. Air pressure is going to pressurize this disc, and that's going to put a force on this rod, which is now connected to a resin pump down here. So the air pressure, the big area, translates to the load on this rod, which transfers to a smaller area in the fluid, and this pumps the fluid. So this down here is the resin pump. What we're seeing up here is your air motor. Okay, and then what you have over here is what's called the slave pump or the catalyst pump. And the reason we call it a slave pump is because it's attached to the resin pump through these arm systems. And how this works is every time the actuator, the pump goes up and down, this little arm swings and causes this pump to dispense a small amount of catalyst. Remember, catalyst is going to be like 1.25 to 1.5% by weight ratio of the resin. So we need a relatively small amount of catalyst relative to the resin. Now downstream, as we get to the gun head, these will mix together and come out. So how we adjust our catalyst level on the gun is simply by moving this catalyst pump. So as you can see here, our fulcrum for rotation is here. So as this actuates, I get a small swing arm, I'll get a small amount of catalyst. If I bring the pump way out here, I'm going to get a tremendous amount of motion, and I'll get a lot more catalyst. So we'll move that pump in and out to get the resin to catalyst ratio we want. All right, so let's focus on the pump mechanics. So what we talk about with a pump is a pump ratio. It's really simple. What it is the ratio of air pressure to fluid pressure. We ignore the catalyst pump in this case. Okay. So if we have a 10-to-1 pump, what that means is for every 1 psi of air pressure I put in, I'll get 10 psi of fluid pressure. So if in this case, if I set my pump to a 70 psi pressure and a 10-to-1 pump, I will create a fluid pressure down here of 700 psi. Okay. Remember we talked about those discs being different sizes. That would kind of tell you that that disc has 1/10 the area of this disc. Okay. So what's important here is we're taking shop air at 50, 70, maybe 100 psi. We're using this leverage apparatus to create very high fluid pressures. So it might come to your attention, 700 psi is a lot of fluid pressure. Your house water pressure is closer to 70. So as we work with these materials, we have to be careful to understand what the high pressures there are, and if we're going to work on the equipment, we need to understand how to depressurize it, because you certainly wouldn't want that pressure coming loose on you inadvertently. So now let's move up to the gun head a little bit, and we talked about spray up method, and now we're going to get inside the chopper gun. You've seen a couple pictures of it, and the overall operation, the glass strands are coming in here, getting chopped up inside the chopper head and thrown out the chute, colliding with the resin, the catalyzed resin that's coming out, and getting sprayed onto the part. Okay. Now open up this cover, and here's what it looks like inside. And so what happens is that roving is going to come in through this guide, okay? And then it's going to get between the feed wheel and the tensioning wheel. And this is an adjustable force that's clamping that fiber. As that fiber comes in, now it goes to the cutting wheel. And if you can kind of see it here, those are razor blades, or little blades, knife blades, that are going to be on this wheel interacting with this rubber wheel, and they're going to be cutting the fiber. So the spacing of these blades actually determines the fiber length, right? So if I have the same diameter wheel, and I have more blades in it, I'll get short fibers, and if I have less blades in it, I'll get long fibers. And you can adjust fiber length by doing that, putting on different number of blades or getting a different blade orientation on the cutting wheel. All right, so once the material comes through here, it gets pinched between the rubber and the cutting blade, it gets chopped up, it gets thrown out the chute and ejected into the resin stream and onto the part. Okay, so one little detail that's interesting is this metal is, the fiberglass is actually pretty aggressive and abrasive. So one thing you'll be able to buy is they make liners for the chute, and it's a metal liner that you can put in here because the glass eventually starts eroding, wearing away the metal. So having a metal liner in here lets you replace that and not have to change this whole cover. Okay, so we saw the gun. Now here's the whole apparatus. So chopper gun, spraying resin in, with the chop feed onto a part. Hoses are connecting it back here. Let's go over here. Now you can see this is the air motor. Okay, that's that air motor we were looking at. Down here is the resin pump. Here's our catalyst pump. Okay, here's our catalyst. Okay, and basically all these chemicals are being brought to the gun head. Here at the gun head, they're mixing together and being sprayed onto the part. So with the chopper gun, when we're doing the spray up method, the worker skill level and the pattern and the body motions are really important, because we're not just putting the resin down, we're putting the fibers and the resin down. So when we have rolled goods, we're pretty certain that we can look at it, we've got the right fibers in the right place. When we're working with the spray up, we got to be more careful, because the skilled operator versus the unskilled operator can be a tremendous difference in the amount of laminate, the consistency of the laminate. So the way to do that is through training. And much like we talked about controlled spraying for the gel coat, now we're going to talk about a similar process for chop. And it's really neat is that these two methods are really the same, so you don't have to remember anything different. It's just the particulars coming out of it. Now we're spraying fiberglass and resin, while before we were spraying gel coat. Okay, so we need to make sure the gun's set up. So we have three components now. Before, with the resin gun, before with the regular resin gun and hand lay, we got the resin and the catalyst. Now we got the resin, we got the catalyst, and we got the glass fiber. And we want to get this done efficiently and in a good loop. Okay, so the first step is, remember, going all the way back to the gun, pick the right tip. You want to pick the right tip for the size, for the job you're going to do. With that tip installed, you want to build up the pressure in the pump to get the proper spray pattern. So I've got a good spray pattern. Next, I want to get my catalyst ratio dialed in. I'll make and adjust my catalyst ratio. With the resin, catalyst ratio, initiator level set right, now I can adjust my chop level. And I will do that by adjusting the power, the air, going to the chopper head. The chopper head is another air motor. And that air motor is running on compressed air. It's got a little adjuster valve on it, and you can increase that air pressure or decrease it. So if you increase the air pressure, the wheels spin faster, you're going to get more glass. If you decrease it, you're going to get less glass. So now with the gun set, resin ratio set, catalyst level set, now you dial in the glass by adjusting the chopper motor. Okay. Now we have the proper resin to glass ratio. We're ready to start the part. And what we're going to do is we're going to band the perimeter first. Gee, that sounds familiar. We band that perimeter. We'd like to not get material outside of our flanges. That's the objective. Okay. Then next, we're going to come onto the part. We're going to pick a orientation, and we're going to spray in a set pattern back and forth with a 50% overlap between passes. Okay. Now, in the gel coat, we had a mill gauge. With chop, we have a chop gauge. Same idea. Now it's measuring chop, calibrated a couple ways. One of those is to ounces per square foot, because that's what we buy for the rolled goods. All right, so we're going to do the same thing. We're going to do the 3-pass method. We're going to pick an orientation. We're going to measure how we did. We're going to adjust our brain. We're going to cross orientation. So if we went horizontal on this one, we're going to go vertical on this pass. We're going to do 50% overlap. We're going to check again the amount of glass, and then on pass 3, we'll have a chance to hit it right where we want. Okay, and we can hopefully get a nice even chop distribution. Okay, and some parts may require more than 3 passes. A lot depends on how thick the laminate is. All right, so let's just go through a checklist here. So if we're setting up the chopper gun, and we're doing a skin coat job in this case, we'll be inspecting the gel coat first. We're going to be making sure that the equipment's in good shape. I have air. I've got all my material there. I've got everything I need. Equipment's running good. Now I got another thing to look at. I've got to worry about the amount of chop I got. So the glass is coming in big pallets on creels. Do I have enough glass to finish the job? And is the pathway from those creels all the way to the gun head clear, or do I have things that are going to mess up my glass feed? All right, so we add that to the list now. Okay, remember we're going through that. We're going to set the tip size first, get the lowest pressure possible. We're going to set our catalyzation level. We're going to position our chop chute, and now we're going to adjust the resin to chop ratio at the end. Okay, think about it. If we didn't do it in this order, if I go back and change something like the resin, now I got to go back and do the catalyst and on and on and on. So we're trying to make this happen very quickly without getting into a loop of a lot of changes. Okay, so you would adjust the chop motor to get the proper resin to glass ratio. You have the chop blades, the number of blades to determine the chop length, and then you can position that chute, and that's going to help determine how the fiber is distributed as it impacts the resin stream. Okay, if you need to readjust, at that point you should be just adjusting the chopper motor. Okay, great. So let's go to the skin coat. All right, on the skin coat, we ideally don't want to just start blowing chop. So with the chopper gun, there's a slide device on there that turns on and off the chopper head. So all the chopper guns can become resin spray guns. So you want to start by disabling the chopper motor. So slide the chopper motor off, and then you're going to fully press the trigger. Okay, and you're going to lightly wet the surface of the tool with resin. All right, and what that's going to do is it's going to put a layer of a wet film down so that when we blow chop in there, we're going to have a less tendency to trap air, and also we like that nice resin-rich layer up against our gel coat, particularly for boats, because we're trying to mitigate against water absorption. All right, now with that done, I turn my chopper motor back on. I fully depress the trigger. I'm off the part, just like I did with gel coat. Chopper motor comes up, everything comes up to speed. Do the perimeter first, okay, and then come in with the 50% overlap method we just discussed. Okay, you wanna do the build in several passes. Now, if it's a really thick laminate, you may do 2 or 3 passes and let the crew come in with rollers and everything else and consolidate, and then actually come back again and put more chop on it. Remember that chop, before you consolidate, it kind of looks like cotton candy, so you wouldn't want to get too much down before you start working it. Okay, if you get it too thick, it's going to be hard to find those air bubbles. So probably about 3 to 4 ounces per square foot of gun roving is kind of an upper limit before you want to start consolidating and rolling. All right, now with that done, we've got to clean up the gun, clean up the area. So if we have any catalyzed resin or uncatalyzed resin, we've got to dispose of that. A lot of guns have what's called internal mix. In other modules, we're gonna show you how these guns work. So some guns are the catalyst and the resin are mixing inside the gun head. Those guns have a flush system. It's really important that we flush the gun out, because if we don't, we're going to catalyze the resin in the tip of the gun, and you're probably going to cause a good bit of maintenance the next time somebody tries to use it, so the gun won't be operational. Make sure a bad manufacturing day when that happens. All right, before we leave for the day, we want to disconnect the chemicals from the pumps. In big factories, that could be a valve that you're actuating. And also, you really need to shut the power off to the pump. So what was the power? Oh, yeah, what was that? Oh, power is air pressure. All right, so we want to disconnect the air from the pump, okay, because these pumps, depending on the age of the system, A lot of those pumps, what's stopping it from coming out is the fact that the gun head is closed. And so if a hose breaks open in the middle of the night, that pump will start pumping and pump the whole factory full of chemicals. Okay, so by disconnecting it from the chemicals, shutting off the air, okay, we are doing the good thing there. And then another little tip is the pump. Okay, we want to try to drive that piston down so that the resin piston is in the fully down position. So as you watch that pump and you start seeing them, take a look at that piston pump. As it comes up, it's all wet. Well, that's because it's wet with resin, and there's a seal that's wiping it. So if you leave the pump in the up position, all that wet resin sitting there, and then all night long, all the dust and dirt, and the guy comes and sweeps and cleans, all that crud is going to get attached to that wet resin. And then the very first stroke in the morning, you're going to push all that in and damage the seal. So by putting the pumps in the down position, you eliminate that issue. Okay, good little tip of the trade. Okay, so as we're going along, we've set up the gun right, things can happen. All right, so if we see that we have dry chop, right, what would be the right thing to do? Well, we're not going to go back and adjust the resin. We're going to adjust the amount of chop. Dry chop means we have too much fiber. We're going to lower the air pressure to the chop motor. If the chop's wet, we would do the same thing, except now we're going to increase the pressure to the chop motor. So if we're wet, adding more pressure to the chop motor is going to get us more fibers, and we'll have a higher fiber ratio. Okay, if we're seeing strange things with the blade, with the fibers, if you're seeing uneven lengths, or you're seeing what's bent fibers, they didn't get broken, they're getting bent. And that's a good sign that it's time to change the chopper blades. So in a busy fiberglass shop, those are getting changed daily. Okay, in smaller shops, if you're not doing it daily, you got to keep some way to keep track so that you know when to change the blade. Okay. So chop length, again, is affected by the number of blades that are in the wheel, and you can get different wheels. Okay, we talked about spring back. That spring back is caused by dull blades breaking the fibers, so you have little L shapes that want to stand up. Okay, and it's really good as you develop your skills, make a part, cut along the length, look at your trim edges. When parts are trimmed, that's a great way to tell how well you've chopped. If you see a nice even thickness, you're a good chopper guy. If you see your laminate varying by 30 or 40 or 50% as you look across it, then you want to start thinking about changing your technique and getting a more consistent technique. Okay? Too much resin, it looks nice, it's shiny, it's beautiful, but it's not good for composites. So we don't want too much resin in the laminate. It's going to create heat, print through, resin's brittle, and it cracks, right? The same thing, if we see the fibers should be going clear, glass fibers should be going clear, and if I see white fibers in there, it means I probably haven't worked it well enough. Okay. All right, great. That takes us through some of the equipment, and we'll be on to the next section soon.